Okay, this is the second video in the sound sequence, and we're going to talk about hearing. We talked about in the first video about the vibration and propagation of waves, so we're going to talk about the hearing part in this one. There are three main sections of the ear: the outer ear, the middle ear, and the inner ear. So the outer ear consists of the pinnae, or the outer folds, like the part that when we say, wow, they have a big ear or they have small ears, that's the part we're talking about, the part that you can see on the outside, as well as the ear canal, which is the part that gets us to the inside here. That's where the wax builds up. The outer ear is actually very important in how we spatialize sound, how we tell where sounds are around us. One of the characteristics of sound waves that we're going to learn about is that waves will go around objects or obstacles that are bigger than the sound wave. So that's why bass frequencies travel really far, because bass sound waves are large. So you can hear bass, it'll go around things, but very high frequency sound waves are much smaller, so they can even get filtered by our ears. So if something is behind us, we'll get less high frequency content than in front of us because it's filtered by the shape of our ears. So that's one of the ways how we can tell if things are in front of us or behind us. And then side to side is the same. If a sound is coming from my right, my left ear hears the version that's filtered by the presence of my head. And also there's a time differential. It gets to this ear before it gets to that ear. So those are some of the ways we figure out where sounds come from spatially. So the sound comes in here, travels here, and it vibrates the eardrum. So this is a little membrane that's connected to these bones of the inner ear, which essentially like amplify the vibrations of the eardrum. And then they are connected to the cochlea, which is part of the inner ear. So what this is it's a big like rolled up tube that's essentially full of fluid, and it's got little hairs in it. And there's going to be another video in this sequence that will, in a very entertaining way, describe how that works to you. And then when these little hairs vibrate sympathetically with the sounds that come in, they trigger the nerves that go to our brain that help us interpret that as sound. And different hairs vibrate at different frequencies. So that's how we put together the overtones, how we can hear more than one pitch at a time, because different parts of that system are responsible for vibrating at different frequencies. That's also how, like, we lose some high-end hearing as we get older, because the parts of that system that are responsible for the higher frequencies get old and stiff and wear out. It's sort of like having to wear glasses, reading glasses when you get older. Lots of things on us last longer than they were possibly intended to. But this is the basic anatomy of the ear and sort of how it works. And a lot of the way we've developed modern sound equipment is very similar to this, right? So like this inner ear functions like an amplifier. Or middle ear rather, functions like an amplifier. The inner ear functions like a filter bank. It filters things and lets us know what sounds are present by frequency. And that'll make some more sense when we talk about synthesis later in the semester.